Hello YouTubers, welcome to my channel. This is gonna be an overview of my new PEMF unit here. This is the circuit that it's based off of, although it has some additional features, and here it is. Alright, so what is it? This is a 2-channel PEMF machine. Pretty strong PEMF machine. It will draw about 1.2 kilowatt out of your outlet on a peak. It's got large capacitor bank and it can output over a Tesla at high frequency. It can pulse up to 600 Hertz and can go down to 1 Hertz, and you can adjust duty up to 30%, between 1 and 30%. You have coil voltage here, adjustment for both coils. You can go 80 volt, 160, 250, 320, or 410 volts. This is your voltage on your coil. This is a digital power meter. It tells you what voltage you're working with, your current draw, your power draw, and your total energy consumption. Here is the frequency generator. You can generate frequency between 1 to 600 Hertz and duty between 1 and 30%. You have a position switch here you can switch between built-in internal generators, and there is 2 of them in here. One has 432 Hertz, another one 528 Hertz. If you select any of them, you will have an ability to adjust the duty for those frequencies between 1% to about 30% here. Also, you have a line input on the back of the unit. I have an input, and you can feed your signal into it. For example, you can feed 5 Hertz for 5 seconds, and then you can feed 10 Hertz for 5 seconds, or 20 seconds, however long you want, and so on. You can feed basically like a program into it. Also here, precise frequency and duty meter. This will measure frequency as being generated either from this function generator or from built-in generators here, and it will output here very precisely to 0.1% accuracy, 0.2% accuracy. You have an ability to change between duty or frequency by pushing this button here. You can turn it off and on and reset this frequency / duty meter. There is 2 outputs here: master coil channel A and slave coil channel B. There's a couple warnings here, and wait for this. Thought I'd show you that. This is how it looks from the side here, and this is the other side here. So what I have here, a capacitor bank. Each capacitor is 1600 microfarad, 450 volt. There's 4 of them here. Then I have 2 transformers. These transformers are toroidal transformers. They are 300 watt. And here I have relays. They control transformers and switches the secondary winding in between to get different voltage output to the coil. Here is the board, controls it. Right here is the whole board. On the top here I have a motherboard. This is the motherboard here. And then I have a power supply, 12 volt power supply, and the front panel here. I have internal cooling. There's exhausting fan. There's fan, cooling fan for MOSFETs, and there is going to be additional fan here installed on a lid, and it's going to be blowing the air inside the unit from outside. Alright, here is how it looks from the front. So guys, I finally was able to clean up the wiring inside this unit. It looks more cleaner, although it still has a lot of wiring here, but for the most part they are going where they need to go, and there is no additional wiring hanging anywhere. This is going to be connected to the fan that's installed on a lid here to blow additional air from outside into the unit, and that's how it looks from the outside. Coils. My new coil. Check this out, you guys. 2 inches wide, 1 inch inside diameter. It's about 5 inches outside diameter. It's made out of aluminum wire, 13 gauge, and it's pretty light. It's about 3.5–4 pounds compared to my copper coil, which is made out of copper, 14 gauge. It's about 9.5 pounds of weight. 1 inch inside diameter, 5 inches outside diameter. This coil is 2 ohm. This coil came out to be 1.8 ohm. So let's give it a test. Alright, let's test it. This is the power all the way up to 400 volt. I'm gonna go frequency generator, and I can switch between 432, 528 and line input here. Right now it's set to frequency generator. Okay, and then I'm gonna increase the duty to about 30%. You can hear the coil. So I will increase it to 30%. This is how fast it discharges the capacitors. And then I have my Tesla meter here. set to pick up the highest value. Here I have my probe. I will set it and take a measurements. And one more time. 0.639 Tesla. 0.639 Tesla at 95 Hertz, 30%. So and if I go to 432 and then I increase the duty all the way up and measure, and I reset value and take a measurements, and I am getting 0.5 Tesla, guys. 0.5 Tesla coming out from this. And look at the wiring. The wiring is moving. See that? So much magnetic flux generated that it pushes this wiring apart. And if I change to 528, it will pulsate 528, and I can decrease the duty here. And if I increase the duty, decrease the duty, increasing the duty. Once I increase to certain power, it starts to burst because it doesn't have enough energy to sustain the power output. So it takes some time to recharge the capacitors and then feed all the power that you want into the coil. So that's about halfway, and I go higher. Let me show you other things here. Here is the frequency meter that's measuring currently 527 Hertz, and if I switch to duty, it'll tell me that my signal is 10.9% on duty. 10.9%. Alright, so the idea is for this coil is to have a fan to constantly blow the air through it, making sure it's not overheating while it's operating, so that session time could be expanded to unlimited time. We can use this for as long as we want while we're actively cooling it. 0.5 Tesla, you guys, going 528 Hertz, half a Tesla. Okay, so my next step is to add thermal sensor here, also possibly south pole indicator on one of the sides of this coil. So I will have to add 2 more wires to here, make additional connector probably right here for each coil, one here, another one here. Also I will have to add blinking red LED, thermal protection LED, possibly right next to it, right here, and another one right here. So those are the things that I need to do, and also encase it. This needs to have some kind of casing, because right now this is like a raw coil. So that's what I got left to do here, and I think that's about it. I'll be having another video showing you guys when it's all complete, probably in another week or 2 from now. But for now, that's about it. If you like the video, give me thumbs up, subscribe, hit the bell, and I'll see you in the next one.